Welcome to another Aberlink 3D tips and tricks guide. If you're spending time creating the same features and dimensions over and over again, this is a tool you need to know about. Feature and Dimension Array lets you instantly replicate features, dimensions, tolerances and annotations across circular patterns, grids, mirrored layouts and even irregular feature arrangements. What could take minutes to create manually can often be done in just a few clicks. Let's look at some examples and see how Feature and Dimension Array can significantly speed up your programming workflow. So we're going to start initially with a very basic feature array, and in this example we'll use a ring. So you can see the part here, it has a bunch of PCD holes along the top. What's interesting about this one is these are threaded holes. So the idea is I've went in already and measured the feature, so just one of the circles here, you can see it here now. I've already changed it to take 4 points with a set pitch of 0.75 at a set penetration. So I only need to do the modifications for one of them. That's the whole idea around feature array. And then I only need to create the dimensions for one as well. So I'll create the diameter and roundness. I'll also create a position callout. For this I'll do a polar coordinate. I'll set it up to fit through A, B and C. Just set up some of the parameters for this. So we'll do just the radius and the angle. This radius is supposed to be 66.3 and 70.2. Hit the green tick. So you create that tolerance there. And then rather than go in and measure each remaining PCD hole, modify the pitch, modify the penetration, add the diameter dimension, add the polar coordinates dimensions, which takes a lot of time, we can do it through the feature array. So feature array, we're going to select ring. The features we're going to copy are just this one circle. We click next. Center feature, so it needs a feature to be centered around. We're going to use the central reference circle here. It automatically defaults to 6, but you can type whatever you want in and it gives you a template of what it's going to create. In this example, it is actually 6, so I'm going to hit 6. We can do a start and end angle. We can go anti-clockwise or clockwise. That obviously matters if we don't do 360 degrees as a sweep. It automatically works out the angle itself. And I'll cover it in a later example, but you can also get it to rotate A and B probe angles if you have used a AB angle to measure the features. I'll hit the green tick and you'll see there automatically it's created those features in the program, but also applied the dimensions and matching tolerances from your initial feature. You can see that saves a bunch of time. We would simply just press play now. That will run the whole feature through, or we can go to our program details, right click on the first grayed out circle and select play from here now, and that will run the remaining features. This is a slightly more advanced example of the ring array feature. So you'll see we've got a through hole here that rotates around the central cylinder. So it's not just a standard straight down A0, B0 ring array. It is a rotated angled ring array using a AB angle other than 0, 0. So I'm at 90-90. I've measured the cylinder. You can see it here. So I've measured the cylinder already and I'm going to copy it round. As I said before, make sure you dimension up and make any modifications to the cylinder. So in this particular case, I've tweaked it a little bit by taking a point pattern of 3, 5. As you can see, I've created the dimension here. And once we've done that, we can then go ahead and use the feature array. Select ring just like we did before. The feature we're going to copy is the cylinder itself. Click next. The center feature, this can be the reference circle I've used at the top or the central cylinder, doesn't matter. And you'll see it rotates now around that with a set amount of items. Again, we can change this to whatever we want. In this particular case, again, it is actually 6. But the thing here is we're making sure that the rotate probe AB angles is ticked. So it rotates the AB angles to get optimal access to each feature. Once we're done, we hit the green tick. So you'll see it automatically creates those. It automatically creates the corresponding dimensions. But what's really cool in this case is if the probe angles that it recommends for these features aren't already built in Probe Manager, you'll see it adds them there automatically. So you can go and datum them now and then run the program. So that is the slightly more advanced AB angle feature array for a ring. We're now going to take a look at the grid functionality for the feature array. In this particular case, you'll see I've got a plate with a bunch of evenly spaced holes. So I've already done the program. Initially, I've got the datum A plane, that's a reference. Datum B is the front face, datum C is the left-hand face. And I want to know the position of all of these holes in relation to that datum frame. So I've already measured one of the holes. That's all that is required in terms of programming. We're going to right click on that. I'll just show you. I've went in, already put the pitch in. So it's an M6 by 1mm pitch. I've put that in. I've changed the amount of points. All I need to do now is create the dimension. So I'm going to double click on it, right click, choose position Cartesian. And then I'm going to right click and add the ABC datum frame. So that's fitted through there. Hit the green tick. That's now created. So what we're going to do is we're going to go to feature array. And this time we're going to utilize the grid checkbox. So instead of ring, we're now going to use grid. The features we're going to copy are this circle. We click next. And then in this particular case, all we need to do is define the items left, right, up and down with the spacing. What you'll also notice is there's a plane and line feature. This is for anything that isn't standard in X and Y. So if you've got things running off at an angle, you can do it. You can define a plane and a line, and then it will rotate and align the left, right, up and down to that plane and line feature. In this particular case, we don't need to do that. So all I need to do is tell it how many items are to the right. So if we look, we've got 8 items to the right. So we put 8 items in here, 6 items up, and the space in between them is 25 millimeters. And you'll see that creates the initial template in turquoise. When we're happy, we hit the green tick, and that creates all of the position callouts like so. These can be tidied up later, but they are now all in the program. See, there's 67 circles there. All we need to do is right click on unit 6, which is the first grayed out one, play from here now, and that will automatically run and then update the dimensions for every single one of those holes in the plate, saving a ton of time. So that is the grid feature within feature array. We're now going to look at the mirror feature within feature array. One thing to just clarify before we do start though, when you go into feature array, you'll see there's 2 different options for mirror. So there's the checkbox for mirror, and then there's also this icon where you hover over it, it says mirror inspection. The mirror inspection has its own video tutorial, so if that's what you're trying to do, i.e. mirror the entire inspection for a right hand, left hand type part situation, please go and watch that video. That's not what we're covering in this particular example. For this, we're covering the mirror feature within a single inspection program where we have a range of features within the inspection that we want to copy. That leads us on to this example, so hopefully you can see this in the video now. I'll just zoom in a little bit so you can see it a bit better. There we go. So what you'll notice is we've got the feature. Basically it's a 3D printed custom fixture plate that I've used for locating some sample parts. And the idea is we've got these pockets and V and holes on the left hand side and the right hand side. The ring array doesn't apply, the grid doesn't apply. So in this particular case, this is where mirror becomes really, really useful. Hopefully you can see on the screen already, I've measured the features that we need. So we've got the angles of the cutouts, some widths, the V angle, the 2 holes at the top and bottom, along with the distance between the 2. So we've got everything done on the left hand side. We just want to copy it now to the right hand side and save ourselves a bunch of time. Before we start, however, when we use the mirror option, so this mirror checkbox within feature array, we need to make sure that we've actually got a mirror feature that we can use to create the copy of the features, i.e. like a center line. Within Aberlink 3D, this has to be a physical plane or a physical line, and if neither of those are available, like they aren't in this example, it needs to be a constructed plane. Constructed lines do not work, so don't try to use a constructed line. It's quite important. Now, obviously I don't have this in this example. I don't have a physical line or physical plane running through the center of the part on the y-axis to be able to mirror from. So I'm going to show you some tricks to construct those features, and then we can use the mirror array to copy the features. Firstly, we want a plane running through the middle, but we can't do that without having a line. There's a few different ways we can do the line. I'll show you two examples right now. If you've already got a alignment line, let's say, that is 90 degrees to the line that we want, we can simply construct the line, double click the line that we want to offset the angle from, and you'll see we can either offset it an amount or offset it an angle. So if I put 90 degrees in here, you'll see that creates the line that we need. That doesn't quite work in this example because it's not on the center line of the part. So in this particular case, I'm going to use line construct from the center circle. So this is the origin of the part. So if I double click the circle, then hit the green tick, it's going to create a line that starts in the center of the circle, and then I can put the end coordinates in. If I just put a y-axis, let's say at 50 millimeters, you'll see that creates a line starting from the center at y50. I left the x and the z blank, so they stay as 0. Now this is only the first step. We've got the line, but remember we can't use a constructed line. So what I'm going to do now is construct a plane. So plane construct, and I'm going to create it from the top plane, rotate it through the line that we just created. So the construction is from the top plane through the line we created, and what it's going to do is it's going to take that plane and create a new one rotated around this line. So if I put in 90 degrees as the rotation, that has created the plane slicing through the middle of the part that we can use as the mirror feature within the feature array. So hopefully that wasn't too confusing, just a useful little tip and trick on some different types of construction that you might not be familiar with. And like I said, now we've got that, we can go ahead and do the mirror feature. So click on feature array just like we have before. This time we're going to check the mirror option, and then the features to be copied, we're just going to go around and pick off the features that we've already measured on the left hand side. We don't need to select the dimensions, they will just transfer over. At this stage we are going to hit the blue next arrow, and then when it asks us which mirror feature, we're going to select the plane which we constructed, and you'll see it gives us a template just like it did with the other ones, the ring and the grid. Gives us these templates of the mirrored features. We hit the green tick and it automatically creates the dimensions to suit. And just like we did before, all we need to do at this stage is go to inspection, program details, right click on the first grayed out feature. That means it's a feature that's in the program but hasn't been ran, and select play from here now. That will then go through, run the remaining features and update all the dimensions to suit. And there you go, you've just saved yourself a bunch of time on a symmetrical part where we use the mirror feature array option. In this final example, we'll be looking at dimension array. To show you where this is used, this is a classic example here. We have an array or a random pattern of 8mm holes scattered across the edge of this casting. Obviously with feature array, we have the ability to do the ring, the grid and the mirror, but that doesn't apply to any of these holes because it's a random pattern. However, what we can do is quickly pick up the measurements of the features. In this example, I basically used store points in feature predict to quickly go around and gather all the data on the measurements of the circles. And that results in what you're seeing on the screen here. So you can see this pattern of 2, 4, 6, 8, 10, 12 holes that I've managed to quickly measure. However, the time consuming thing again is setting up the identifier, nominal, tolerance band, and if there's any other dimensions, in this case I'm going to do true position as well. It's very time consuming to do it for every single one. So we'll start off just by creating the dimensions. So I'll start off with any one of them. I'm going to pick this one in the bottom corner. I've created the diameter and roundness there, and if I right click on it I can give it a name. So let's call it 8mm through hole. It's supposed to be 8mm, so I'll change that nominal. Tolerance band is 20 microns with a 20 micron form limit. Hit the green tick. So you'll see that's created it as normal. And to go through and do that on every remaining one takes a lot of time. However, if we right click on the dimension again, you'll notice there's a feature array icon similar to the one we were using on the toolbar earlier, hidden within the dimension window. If I click on this, you'll see it says copy dimension from similar features, and that applies those dimensions to all the remaining holes. So we can move this around. Now, you could put these in different layers as well, but obviously I'm not covering that in this video. And if we right click on any one, you'll see it's got the same identifier, the same nominal, the same tolerance band, and the same geometric limit, saving that time. We can repeat the same thing for something like true position as well. So if I create the true position for that hole, right click on it and copy to similar dimensions. Again, it's automatically created a position dimension on all those remaining features. So that is dimension array, and it's a sort of alternative method if the ring, grid, or mirror do not apply to your feature set.